Hey guys, so this is going to be an overview of all of our different tectonic plate boundaries. How do they move? What do they look like? And then what are the effects that they have on Earth? So first, let's review our two types of crust. So we have our oceanic crust and we have our continental crust. So continental, we know, is a little bit thicker than our oceanic crust. So not only is it thicker, but we know it's also less dense. And we have our oceanic crust over here, which, just like pizza, thin crust, yes, it's thinner, but it is more dense. So remember, at any time during this video, if you want to pause and write something down in your journal, that's the beauty of it being a video. So let's start with divergent boundaries. So divergent reminds me of the word divide in math. Whenever you divide a number in math, you're just splitting it apart or you're spreading it out. Same thing for divergent boundaries. So first we're going to look at divergent oceanic. Remember, I want you to draw this in your journal with me. So we're going to have two pieces of thin oceanic crust. Remember, since it's the ocean, it's going to be underwater. Okay, so because they're divergent, we're dividing them. They're actually traveling away from each other. So what does this result in? Well, this is an effect that we call seafloor spreading. Oops, seafloor spreading. Make sure this is in your notes. Whenever you have seafloor spreading, it creates what we call mid-ocean ridges. This is where the two plates pull apart from each other, and so then that allows magma from the mantle to flow upwards. And as it flows upwards, it comes and it hits the ocean floor, and it spreads, and because of the temperature difference between the mantle, which of course is heated by the core, and then the ocean water, this magma comes up and it rises, and then it spreads out and cools, and it begins creating new land. So here's the main points that we need to make sure that we've gotten so far. At a divergent boundary, which is where two plates spread apart from each other, specifically these are going to be oceanic plates, we get seafloor spreading. This creates mid-ocean ridges. At the mid-ocean ridges, it creates new land underwater as the magma rises and then cools and hardens. Now you're about to see a couple pictures of some examples. So in this example, you can see where it shows the magma coming up from the mantle, rising up due to the convection currents, coming out of this seafloor spreading right here, the mid-ocean ridge. You can see the two pieces of crust moving apart from each other. So then as this magma rises, it's going to come through right here and start spreading out and cooling and create new land as the plates spread apart. This is a map showing where all of our mid-ocean ridges can be found. This is the Mid-Atlantic Ridge. This is our longest mid-ocean ridge. This is the example we most often will see and use. Now, you can look at the other examples, and you're going to notice that you're going to be able to tell that a mid-ocean ridge has formed here because these arrows are showing you where all of these different plates are separating or moving apart from each other, which we know is a divergent boundary. So now let's look at divergent boundaries with two continental plates. So here is our main pieces of continental plate, and then we have something kind of interesting start to happen. So we know down below the continental plates, this is going to be our mantle. So what gets created here on top of the Earth is what we call a rift zone or a valley. So the rift zone is a dropped zone where the plates are actually pulling apart from each other. So we know that these plates are moving this way. And then your rift zone or your valley is this piece right here. So as the crust widens and thins, the valleys are going to start forming, and around the area, volcanoes could start forming here as well. So again, if you're not sure what to write in your notes from that, go ahead and pause your video right here and copy this down. This is a real-world image of what a rift valley looks like in between two continental plates that have diverged. And then here we have a pretty good visual representation of what happens at this type of divergent boundary. So again, you still have your magma coming up from the mantle, your two pieces of continental crust going opposite directions from each other, and this right here labeled lava conduit and lava flow. So all that means is where this magma is slowly flowing up, and remember it's magma because it's under the crust. Once it comes above the crust, it's lava. It just flows really nice and slow, and then again, once it hits the top, just like any other time, it's going to cool down and harden to form new land. Now we're going to move on to our convergent boundaries. So remember that convergent means to come together or to collide. So your tectonic plates are still moving in opposite directions, but this time they're coming towards each other. So the first one we're going to look at is oceanic and continental. So keep in mind that our continental crust is thicker than our oceanic crust. However, it's less dense. So whenever the two meet, because the oceanic crust is more dense, it is more likely to actually bend and get pulled underneath your lighter, thicker continental crust. So this part, because it's oceanic, we know it's under the ocean. So this is our continental and our oceanic. So what this is going to end up doing is it's going to make a trench about probably right here, where the crust is actually coming down and underneath the continental crust. So remember that a trench would just be like a valley, like a little dip in the land. And what we actually call this right here, where one piece is getting taken underneath another piece, is subduction. So subduction is a vocabulary word that you are going to be expected to know. So subduction is whenever one piece of crust, whether it's two different types of pieces like we have here, oceanic and continental, or two oceanic pieces, if one piece gets pushed down underneath the other one back into the mantle, that's called subduction. So then one more thing that we could have formed, so we know that this is our, oops, still in the highlighter, that this is our trench, is this actually can also make volcanoes. In addition to your drawings, because you're following along, remember, and drawing with me as I draw all of these examples, here's the main points that you need to have in your journal. Go ahead and pause the video here so that you can get these written down before we look at some more pictures. This is a very good graphic representation of a convergent boundary. So we have our thin but more dense oceanic crust getting subducted underneath our thicker and less dense continental crust. And then you can see this line right here represents our trench or our little dip underneath the ocean that got made. And then here's our volcano. And if more than one happens to pop up, that's what we call a volcanic arc. I want you to think ring of fire whenever you think about that. So we're going to move on to our next type of convergent boundary, which is going to be two oceanic plates converging or colliding or coming together with each other. So remember that oceanic plates are thin and they're dense. So if they're both oceanic, how are we going to figure out which one's going to end up getting subducted? Because that's actually what happens. And so the older plate is actually going to be the more dense oceanic plate. And so it's going to end up getting subducted underneath the younger, which is this one right here, less dense oceanic plate. So oceanic plate, we're under the ocean. The interesting thing is because subduction happens, we're going to end up with the same effects that we had whenever an oceanic and a continental plate collide. And so that's going to end up making a trench, which remember is like a little valley underneath the ocean. And then it's also right here going to push up this piece of oceanic crust and form volcanoes. This is how volcanic islands get formed. We call them island arcs. And so Hawaii, our state, our island state, this is actually how it got created. So here's some main points about oceanic convergent boundaries that you need to make sure we've got. When you have two pieces of oceanic crust collide or converge, the older, more dense piece gets subducted under the other piece. Whenever that happens, this forms a mid-ocean ridge or trench, volcanoes, and can result in island arcs, which remember are volcanic islands. This is our last type of convergent boundary, so we're going to look at what happens whenever two continental plates converge or collide together. And this one's a little bit hard for me to draw you a good picture, so we're going to just use a graphic. So you have two pieces of continental crust, and we know that they're not super dense, and so what happens is that they're actually too light to get pulled under into the mantle, like what happens in subduction with two oceanic plates or with an oceanic and a continental. So instead, whenever they start converging, what happens is the plates kind of crunch up and fold upward. And so that's what leads to the formation of mountains and mountain ranges. These notes should be pretty short and simple. Our convergent boundary with two continental plates, this is how mountains are formed and how mountain ranges are formed. So our last type of boundary is a transform plate boundary. Now the good thing about a transform boundary is that it doesn't matter if it's oceanic or continental plates. The same thing happens each time. So you have two different plates, and what these guys are going to do is instead of coming together like a converging plate or dividing like a divergent plate, they are going to push or slip right past each other. So what ends up happening is this is where most of our earthquakes come from. This also makes fault lines. So because these plates basically get stuck together right here, this pressure and this force behind these two massive plates builds up and up over time. And so whenever they finally slip past each other or slide past each other, it just does it a little bit at a time and just enough for us to have an earthquake. Whenever there's a major slip, that's whenever we get a big fault line, and I'll show you a picture of that in just a second. Okay, so I'm just going to run through a couple images of fault lines with you guys so you can actually see what it looks like. So here's our first fault line, and you can absolutely tell where we have some plate movement going on here, this being our fault line. Here's the next one coming up. So same thing happening here. Here's our fault line. Whoops. You can see coming up all the way from up here. So again, we have two plates sliding past each other, creating all of this space in between the two plates. And then our last one is this one right here. So you can almost tell whenever you look at these kind of how they fit together like a puzzle piece. If you look at the edges where they're at and then the edges on the other side, you can almost see where they should have gone together. Okay, so that's our overview about all of our different tectonic plate boundaries. You should have 6 total, and so I'm going to list those here again so you can go back in your journal and make sure that you have all 6 of them written down, you've drawn some examples, and that you've listed what are the effects, such as seafloor spreading, or is there an earthquake, does it make a rift zone, what happens. So the first one you should have is divergent boundary oceanic. So remember, a divergent, they divide or split apart. This is 2 oceanic pieces of crust. The second one is also a divergent boundary, meaning they split apart or divide with two continental pieces of crust. The third type that you should have is a convergent boundary, so this is where they're coming together or colliding. This is going to be between an oceanic and a continental piece of crust. The fourth type is another convergent boundary. This time only oceanic crust is involved. The fifth type is another convergent boundary, this time with two continental pieces of crust. And the sixth and final type of boundary is a transform boundary, which, remember, it doesn't matter if it's continental or oceanic, they both result in fault lines and earthquakes. So if you have any questions, go back through, read your notes a couple times, go back through and watch this video a couple times, and if you still have questions, please let me know.